Hello everyone. Today we're going to explore Lab 5, which focuses on collisions. Specifically, I'll be investigating what happens when two balls collide and how momentum and energy are transferred during that collision. This is a fundamental concept in physics that explains everything from billiard ball interactions to car crashes. In this lab, our main goal is to investigate the dynamics of two balls colliding. We want to understand two key things. First, how momentum is transferred between the objects, and second, how energy behaves during the collision. By carefully examining whether the motion before and after impact, we can determine whether momentum is conserved and whether the collision is elastic or inelastic. This will give us real-world insight into the principles we've been learning in class. Let me walk you through our experimental setup. We have a track system that allows two balls to collide in a controlled environment. This setup minimizes friction and external forces, which is crucial for observing the pure physics of the collision. One ball is released from a known distance, while the other ball is at rest, and we use video recording equipment. Some important equations. Now we'll talk about the physics behind what we're observing. The main concept here is the conservation of momentum and kinetic energy. The conservation of momentum tells us the total momentum before the collision equals the total momentum after. Mathematically, that's m1v1 initial plus mv2 initial equals mv1 final plus mv2 final. This holds true for all collisions regardless of the type. For kinetic energy, we use the equation 1/2 mv squared. In a perfectly elastic collision, the total kinetic energy is also conserved, meaning the sum of the kinetic energies before equals the sum after. However, in inelastic collisions, some kinetic energy is transformed into other forms like heat or sound. This is the observed motion. When we actually run the experiment, we see some fascinating behavior. Typically, we observe that the first ball slows down or even stops after the collision, while the second ball accelerates for a bit and then also slows down. By measuring the velocities at multiple time points, we can create velocity time graphs and verify whether momentum and energy are conserved within the experimental uncertainty. Now to answer the what if question. Let's consider, what if the balls had different masses? How would that affect their velocities after a perfectly elastic collision? Well, if the balls had two different masses, the outcome of the collision reflects that imbalance. The lighter ball experiences a much larger change in speed and direction, often rebounding sharply, while the heavier ball's velocity is only affected slightly. And what does it mean for a collision between two balls to be perfectly elastic in terms of energy and momentum? A perfectly elastic collision means that both momentum and kinetic energy are fully conserved. No energy is lost to heat, sound, or deformation, so the total kinetic energy before and after the collision is identical. This is behind the scenes with Tracker, and this was our setup that we had. This video analysis technique has been used throughout our different lab experiments. Thank you so much for your attention. I hope this is a clear understanding of what we've investigated in Lab 5.